This is Geometry, Unit 3, Lesson 2 on equations of the line. Let's use the equation of line to graph some lines. First one we're going to look at is x equals 3. The equation of line where x equals 3 is telling you something. It's a little strange, but it says x is 3. That means x is always 3. No matter what happens, x is going to be 3. That means that y can be anything. So I can make x equals 3 as many times as I want. Y can be anything. Y could be 0, y could be 5, y could be -1. Any of those values of y can happen, but x has to be 3. So let's see what this looks like. 1, 2, 3, 0. 1, 2, 3, 1, 2, 3, 4, 5. And 1, 2, 3, -1. What have we created when we have x equals 3? We have created a vertical line at 3. There is my line. So when I name this line, it's called x equals 3 because all the x values are going to be 3. It hits the x-axis at 3. So what do you think is going to happen when you have y equals -2? Well, instead of x being something, this says y has to be -2. Y is always -2. X can actually be anything. So I can fill in as many -2s as I want and make up some x's to go with them. We could say x is 1, we could say x is 0, and we could say x is -3. There's my values. X can be anything, but y has to be -2. So let's graph this. We have 1, -2. We have 0, -2. And we have -3, -2. What have we created? Well, we have created a horizontal line at -2. It hits the y-axis at -2. So you can see every single point on that line has a y value of -2. Y has to be -2 no matter what. Now, if we look at y equals -2x plus 3, it doesn't say what x and y has to be. It says x can be anything, but y depends on x. X is sometimes called the independent variable. It's because x can be anything, but to find y, you have to use whatever x that you have to find the y based on your formula. So x is the independent variable, and y is the dependent variable. It depends on what x is. So we can make x anything. Let's say x is 0. That's a good one. And if we plug x into our equation, -2 times 0 plus 3 is going to be 0 plus 3, which is 3. So if x is 0, y is 3. Let's say x is 1. -2 times 1 is -2, plus 3 is 1. So if x is 1, y is 1, based on this graph. And let's try -1 just to be interesting. Say x is -1, -2 times -1 is 2, plus 3 is 5. So if we graph this line, we have 0, 3, 0, 1, 2, 3. We have 1, 1. And we have -1, 5. 1, 2, 3, 4, 5. Now notice this line is slanted. It is a slanted line because the x and the y depend on each other. Whatever x you have, your y will depend on that. It does not say specifically what x and y has to be. You have to figure that out. So you can see horizontal lines have the same y, vertical lines have the same x, and y equals -2x plus 3. This is x and y depend on each other in order to be able to graph a line. So let's look at our summary. In summary, what we've just found, if we have an equation that looks like x equals a, x equals a is a vertical line. It's going to go through a on the x-axis. It's going to look like this. It is going to have an undefined slope because it's vertical. It does not have the bottom coordinate of the slope formula is going to be the same, so when you subtract them, it's going to be 0 in the denominator, so it's going to be an undefined slope. The second one, y equals just some number. Let's say it's y equals b, where b is a number. It is a horizontal line through b on the y-axis. It's going to hit the y-axis at b, and whatever the b value is. and the slope is going to be 0. So your line is actually going to look like a horizontal line. It looks like that. Now, the third one is going to be y equals mx plus b. That's how we're used to seeing them. Y equals mx plus b, where m and b are both numbers, is a diagonal line, unless the m is 0, because then it would be the slope. Now, unless m equals 0, because then it would be a horizontal line. The slope is always going to be m, and it's going to pass through b on the y-axis, so the y-intercept is b. So when you see y equals mx plus b, we've seen that before, it's called slope-intercept form of the equation of the line. So when you hear slope-intercept form, it's saying write y equals mx plus b. So those are the three you should be able to identify when you see the equation of a line. X equals, y equals, and y equals mx plus b. Now let's use the equation of a line to actually graph an inequality. Now we are going to graph the inequality 2x minus 5y is less than 15. First of all, we need to get this in y equals mx plus b form. We're just going to use the inequality instead of an equal sign, but we want this to look like y equals mx plus b. So if we solve this for y, 2x minus 5y is less than 15. We want to get y by itself, so we subtract the 2x and put it on the other side. So that would be negative 5y is less than negative 2x plus 15. I'm putting the 2x in front because I want to look like y equals mx plus b. And then divide by negative 5. I'm going to actually write the divide down because I want to make sure you pay attention to the signs when you do this. Negative divided by a negative is a positive y. Now, we divided by a negative, so what happens to the inequality? Remember, the inequality is actually going to flip because we divided by a negative 5. That's one of the tricks, rules we learned from Algebra 1. Now, negative 2 divided by negative 5. Negative divided by a negative is actually a positive. 2/5 x. And then 15 divided by negative 5 is negative 3. So now this is in y equals mx plus b form. You just have an inequality there instead of an equal sign. So why do we do it that way? So we can pick out the m and the b immediately. Now, according to this equation is y equals mx plus b form, your slope, or your m value, should be what? Well, y equals mx plus b, it should be 2/5. And my b is my y-intercept. That's my b value. If I look at my equation, y equals mx plus b, it should be negative 3. Don't forget the sign. All right, so that gives me some points that'll make my line. Let's try it. My y-intercept is negative 3. 1, 2, 3. My slope is 2/5. Remember, slope means to go up however many and to the right however many. So this means up to the right 5. 1, 2, 1, 2, 3, 4, 5. I can do it again. Up to 1, 2, 1, 2, 3, 4, 5. And if I want to go backwards, you have to reverse both of them. So instead of up, we go down, 1, 2. And instead of going to the right, we go to the left, 5. 1, 2, 3, 4, 5. So we have created the points that make up that line. Now, remember, this is an inequality. The inequality is greater than here. If we have greater than, does that actually equal 2/5 x minus 3? No, it doesn't. So that means this is going to be a dotted line when we draw it. Now, if we draw this as a dotted line, get my dotted line up here. All right, connect your points with a dotted line because it's not equal to. What else does greater than tell us? Well, remember, greater than means the points that make the inequality greater than, makes it true, are going to work for these graphs. So we have to figure out where the values of y will be greater than 2/5 x minus 3. Well, since it's greater than, it's going to be dotted. It also means we're going to shade above the line because it's greater than. Remember doing that in Algebra 1? So this half of the graph up here, any value of x that we pick, will actually be greater than 2/5 x minus 3, and it will make the inequality true. So any value up here will work, any value down here will not work. So the solution is actually up here. So that is graphing an inequality. I'll even label it. This is the inequality, y is greater than 2/5 x minus 3. So solve it to y equals mx plus b first, figure out your slope and y-intercept, figure out what kind of line you're going to draw, and where to shade. That should be reviewed from Algebra 1. Now that we know slope-intercept form, we should be able to write the equation of any line if we have a slope and a y-intercept. So let's look at our equation of our line here, or the graph here, and see if we can write the equation of the line. So here is my line on my graph. We need to know the slope and we need to know the y-intercept. So we need to know the slope, which is m, and we need to know the y-intercept, which is b, in order to write the equation of the line. So if I'm looking at this, the y-intercept is usually easy to pick out. All we have to do is go to the y-axis and find the point. So the y-intercept is actually right there. So the y-intercept, or the b value, is going to be 2. Now, how do we find the slope? You can do it by counting right on this line. All you have to do is find 2 specific points that you know and count left to right to get to them. So I know this point, that's an easy one. Let's see if I can find the next point that goes with that. How about right there? I know that one specifically. All right, how do I get from this point to this point? Well, I have to go up or down. I actually have to go down. 1, 2, 3. So that's going to be -3. And then I have to go to the right. 1, 2, 3, 4. So my slope here is going to be -3/4. So what's my equation of my line? If I have y equals mx plus b form, I now know m and b. It's going to be y equals -3/4 x plus 2. And that's the equation of that line. Now, there is another form of the equation of the line. It's called the point-slope form, equation of the line. It's just another form that you use, and you use it when you have the slope, which is m, and any point on the line, we call it x1, y1, that is not the y-intercept. So say you just had some random line that you didn't know where it crossed the y-axis. You could use this formula to find what the equation of the line is. Now, the point-slope equation of the line formula is y minus y1 equals m times x minus x1. x1, y1, remember, is just some point that we have to work with, and m is the slope. So, using my information that I have in this formula, y minus y1 equals m times x minus x1. Write the equation of a line with a slope of 2/5 that passes through the point -4, 7. All right, now, let's list what we know. We need a point and we need a slope. So my m is actually 2/5. So m is 2/5, right there, because that's my slope. Now, it passes through the point -4, 7. That's a given point that we have. That's not the y-intercept. So this is actually going to be x1, y1. Let me list that over here. x1, y1 is -4, 7. All you have to do is plug in m, x1, and y1, and then solve for y. So plugging it in, we have y minus 7, because that's y1, equals 2/5 times x minus -4. Now, what's x minus -4 actually? It's actually x plus 4. So, this is actually the point-slope form of the line, point-slope. What if we wanted to get it into y equals mx plus b form? Well, we have to do is solve for y. So to solve for y, to get to slope-intercept form, we distribute the 2/5 through the parentheses. Y minus 7 equals 2/5 x plus 8/5. And then, to get the y by itself, we just add the 7. So if we have 8/5 plus 7, you can do that on your calculator if you really need to do that. It's going to be 43/5. Okay, which is about 8.6, I believe it is. So anyway, y equals 2/5 x plus 43/5. This is slope-intercept form. So you can use the point-slope form to get slope-intercept form. You just solve it for y. All right, let's do one more. Write an equation of a line that passes through the points -3, 12, and 9, -8. So, first of all, we need to figure out the slope. We know the slope formula is delta y over delta x. So we have two y's there. -8 minus 12 over 9 minus -3. -8 minus 12 is -20. 9 minus -3 is 12. -20 over 12 reduces to -5/3. So my m is -5/3. So what do I use for x1, y1? I can use either point. It doesn't matter. So let's say I wanted to use -3, 12. I can use either one. I would take them, plug them in the formula, y minus y1 equals m times x minus x1. Let's plug it in and see if it works. Y minus 12 equals -5/3 times x minus negative 3. See if you can solve that for y to figure out what the rest of the equation is going to be.